Oh, hi, team. Just a blast from the past. Just a quick look at some inverse functions. He says, throwing his stylus on the floor. And so, what I want to show you is that inverse functions reflect through this line y equals x. So graphically, we should have something like let's say 2x minus 3. Let's suppose that's f of x. Then this should reflect through the line and become a line. So linear functions, their inverses are linear functions. All right, so this point here, 3, 3. And so I can tell you that the inverse is going to be equal to 1 over 2x plus 3 over 2. There. So that's the inverse function. I just did the algebra in my head really fast. All right, and then if we look at reciprocal functions, on the other hand, if I want to find the inverse of a reciprocal function, let's say I have h of x is equal to 3 over x minus 2. Okay, well, if I reflect that through that line, that's going to be a reciprocal function. So I'm just going to do the algebra here. So let me show you how to do the algebra. All right. So we know that this wants to be a reciprocal function. So let's figure it out. So I'm going to turn on my pen. I'm going to make this the right size. And we're going to go, I'll show you how to do the algebra for these. So if h of x is equal to 3 over x minus 2, all right, so let's write it as y equals 3 over x minus 2. And then we'll switch the x and the y. And you'll know that I like switching my pen at this point. X equals 3 over y minus 2, because I've now actually created a new function. This is the inverse. Now let's multiply both sides by y minus 2. Okay, and that will give us this canceling that. So this equal, and then we'll divide both sides by x. All right, so that will, and this will cancel that. So that will give us y minus 2 equals 3 over x. That's a strange way to write x. My goodness. Okay. All right, so let's go. Okay, 3 over x. All right, and then we're going to add 2 to both sides. So our inverse function, f inverse of x, which I'm going to call j of x, is equal to 3 over x plus 2. Okay, let's write that. J of x is equal to 3 over x plus 2. Oh, look at that. It intersects right at the line y equals x with the original function, because that point reflects to itself. And you can kind of see visually this point there is reflecting to that point there. And all the x, y's have been swapped. Cool, right? Okay, so reciprocal functions invert to reciprocal functions. And let's do one more linear example. Let's change f of x to, we'll do 3 over 5x minus 8. Okay, I'll turn off these functions so we don't have to look at them. And we're going to recreate the inverse of that function. Just going to zoom out. We would expect this point down here to invert to itself. Cool, negative 17 and a half, negative 17 and a half. I didn't know that was going to happen. Cool. And this one over here, 0 minus 7, should invert up here. I can tell you the b value is going to be 11 and 2/3, just because I can look at the line there. And the slope's going to be a reciprocal. So I actually know it already, but let's do the algebra. Okay, here's how you do the algebra for these. So linear functions inverting to linear functions. So we have f of x is equal to 3 over 5x minus 7. We're going to change our pen because we're doing something different now. And we are going to say x is equal to 3 over 5y minus 7. The astute among you know that I wrote this as y equals in my head and then flip the x and the y because I love skipping steps. All right, now let's add 7 to both sides. So we're going to have x plus 7 equals 3 over 5y. And now let's get out an inverse operations pen. And we're going to multiply both sides by 5 over 3. Notice I multiplied the whole side of both equations by 5 over 3. All right, so now this 5 cancels that 5. That 3 cancels that 3. That's why I did that. And then carrying on, we have y. Y is equal to 5x over 3 plus 35 over 3. That's your 11 and 2/3, 35 over 3. Okay, that's distributing this one in. So I'm going to call this g of x, which is actually f inverse of x, which is 5 over 3x plus 35 over 3. And yes, I could have written the whole thing over 3. All right, so now let's put that into Desmos and see if it behaves the way I expect it to behave. So let's turn this on. Notice Desmos does not like that f inverse notation, so I'm just calling it a new function, g of x. So this is 5 over 3x plus 35 over 3. Boop, there it is. Oh, look at that. Everything is perfect. Everything is awesome. So that's why linear functions invert to linear functions and reciprocal functions invert to reciprocal functions. So it actually shows you that there are some functions that are their own inverse. For example, the line y equals x. And there's actually an infinite number of other functions that are their own inverse. And if you want some bonus marks, tell me the family of functions who are all their own inverse, meaning like there's an infinite family. Okay, anyhow, any questions, hit me up by email. Otherwise, bye.